Today I'm going to demonstrate making measurements using the ETEK. This technique uses ultrasound to measure the elastic and engineering constants on a friction material. We're going to take a look at what we call the enhanced procedure, and first we'll calibrate the machine, and then we're going to make load measurements followed by ambient measurements, and we will set up for an elevated temperature measurement. So the first thing that when I walk up to the computer, I will double click on the icon, the ETEK icon. This starts the ETEK software, and the first thing that the operator needs to do is select their name from the list. Okay. The screen that you see is the operator user screen. On the left-hand side, we select from the type of measurement that we would like to do. As I mentioned, the first thing that we're going to do is a calibration, and we will be looking at the ultrasonic waveform in the blue area of the screen. So I take my 1, 2, 3 gauge block, and we're going to be measuring essentially the ultrasonic transit time through the 1-inch direction of this. And I go over to my stage, and I have my shear wave transducers in place, and I'm going to put my gauge block in between the transducers. I do have a little bit of SWC couplant either on the surface of the gauge block or on the transducers themselves, and I am going to apply 700 newtons of load. Now that the sample is in place, we can see that there is a waveform on the screen, and I am interested in the waveform that is about at 8 microseconds. So the first thing that I'm looking at this, and the peaks and the troughs are off the screen, so I need to adjust my gain level here by turning this down by clicking on the down arrow. And if that is not sufficient, I need to add attenuation. This model of the ETEK has a click-in attenuator, so I can either add 10 dB there. For the older models of ETEKs, we supply an attenuator that simply screws into the transmit line. The next thing that I want to do is be able to measure where this trough is. So I want to be able to move my measurement cursor, which is the yellow vertical line. So I'll double click on cursor control and drag the white vertical lines so that they are on either side of this trough. The peak detection, I want that to say minimum, and since I am doing a calibration, I'm going back over to the left-hand side of the screen, and I'm going to select calibration. Okay. Now that we're on the calibration screen, and I have 700 newtons of load in place, I can click the accept, and that gives us the transit time is displayed. And I'm going to repeat this measurement 3 times to complete the shear wave portion of the calibration. Okay. And at this point, I need to change the transducers. I unscrew the set screw that is holding them in place, and set the shear wave transducers aside and put in the compressional transducers. To distinguish between the shear and the compressional, the serial numbers either start with a C or an S, the C for the compressional, S for shear wave. So now that I will put my gauge block back into place and again apply about 700 newtons of load. And the 700 newtons is not critical when we're dealing with materials other than friction material, but just for consistency's sake, we do 700 newtons. Now we're looking at a compressional waveform. I need to change the position that I'm measuring. I want to measure the first peak. So I'm, with my cursor control, I'm moving my white windowing so that my yellow vertical line is over the first peak. And when I'm ready, I click accept, move the calibration block, click accept again, move it, and click accept for a third time. And click OK on save calibration. At this point, a new offset value has been calculated and we're ready to start a measurement.